Okay, thanks for watching. So today we're going to talk about using Interzoid's matching APIs as the basis for matching data across datasets and achieving much higher match rates because of a technique that's AI powered along with knowledge bases and algorithms known as the similarity key. Now, a couple of things before we try this. First of all, if you want to get a trial, you do need an API key since we're actually calling APIs behind the scenes, just a programmatic interface. But this, of course, tool is a no code tool. But if you really want to combine data sets using these similarity keys, the API probably makes the most sense. Even though you can run batch jobs at batch.interzoid.com, we're just going to interactively show how the APIs work here at try.interzoid.com. Here's all the various APIs. In this case, we're just going to look at the individual name matching API. And if you want to find out more about it, you can click on this link right here on the tool, and it'll describe a little bit in more detail the technical details around how the API works. But it's really easy to integrate. It's just a JSON REST based API. And all it does is it takes a name, in this case John C. Smith, and generates an individual name similarity key. Now, here this is essentially just a hashed string which contains some values, and the idea is that it's a canonical representation of John Smith. And what that means is, for example, if I just do John Smith, and you can see the credit number here, I'll click it again. For John Smith, we got the same similarity key. If I take out the H, another common spelling, generate the key again, I get the same similarity key. Again, this is just a row of characters. Now if I type Bill Brown, for example, I do get a completely different similarity key because of all the information that we've encoded. But if I go back and do another variation of Jonathan Smith, maybe with a Y, generate it, we're back to the IL7LPS key. The idea is if you append this similarity key, maybe as a additional column within each data set, and then use the sim key as the basis of the match between data sets rather than the data itself, you're going to get a much higher match rate. So for example, in addition to individual name matching APIs, we've also got an address matching API, and you can generate address similarity keys. So you could combine two data sets on the basis of a join, or just matching places where the name sim key matches and the address sim key matches. You'll get 80 to 90% match rates, commonly, as opposed to 10%, which most people will tell you if they try to do exact matching they can achieve. So the similarity key is very important. And if you want to know how it works from the API, it actually shows you the API that was used. API.interzoid.com is the endpoint. Get full match. Then license is your API key. It's the same thing that we've got hidden up here. And by the way, you can get an API key at interzoid.com, including trials if you want to try it out. And let's scroll back down here. That's where you would enter your license and then the full name. In this case, it is appending a plus sign there for the space, but that's irrelevant. You don't need that. Okay, and so let's just do a few other examples. Maybe if I do a Jennifer Hernandez and I generate a SIM key, well in this case it's SOZB9. They can be pretty long, but it's just a string of text. SOZB9. Let's just say I put an S on there and we're going to call her Jenny Hernandez. Same thing. I'll get the same similarity key. So it gets rid of all the different nicknames and possible spellings and helps you overcome that by generating this concept of a SIM key. Again, it's using AI plus knowledge bases plus algorithms and an understanding And the important thing too is this is not just North American names. It's global coverage, and so you can take, let's just try, I don't know, a German name, Gerhard Schroeder. Get ZZZR. I can take the C out of there. Get the same, so we can overcome that. Or maybe there's a T here and an EDR. Another H. Again, we get the same SIM key, so we'll be able to match on the different variations of the same name. There's a lot of ways that you can use this. You can check for redundancy in a single data set, sometimes referred to as deduping. Not a very technical term, but you can identify redundancy in a data set by using these similarity keys. You'd simply generate the similarity key for every name in the database, and maybe that's part of your matching criteria. Of course, there's probably a lot of Jim Smiths in the world. So if you've got a large data set, you might be matching on other criteria as well, such as a zip code or something, a company name, an address that qualifies a little bit more than just a common name. But maybe not. And you can also use it as a searching mechanism. So if someone's doing a search query and they enter the name like this, Gerhard Schroeder, you generate the SIM key. You can find other records that share that same SIM key, the different spellings of this name, and those will come up. And so it goes way beyond, with the company name, similarity keys that are generated. You can have things like IBM and International Business Machines. Those will generate the same similarity key. So it goes way beyond these little, one character difference types algorithms. Because of the context and the knowledge bases that are built within this, much farther than the typical fuzzy match libraries that you find. And you can try it out. Again, go to Interzoid.com. These are all the various matching APIs that we have that work similarly. In addition to all the different enrichment APIs, there's a lot of different things you can do with this AI-powered data platform, and some tools to make it very easy to understand how they work. I hope to see you. Contact us at support@interzoid.com if you've got specific questions. Otherwise, come and get a trial and see what you can do to improve the ROI of your important data sets and create new opportunities by combining multiple data sets using our SIM key capabilities. Thank you.